This is MSJ Chem. In this video, I'll be looking at the electron configurations of the first 36 elements. Let's start by looking at how electron configurations are written. The number in front refers to the main energy level, so that's n equals 1 or n equals 2 and so on. The letter refers to the sublevel, so that's S, P, D or F. And the number in superscript tells us the number of electrons in the sublevel. So according to this electron configuration, we have 2 electrons in the S sublevel in the first main energy level. So next, we'll look at the electron configurations of the elements hydrogen to neon. On the left, we have orbital diagrams which represent atomic orbitals. These will fill with electrons as we look at each element's electron configuration. So starting with hydrogen, the electron configuration is 1s1. Next is helium, which is 1s2. Moving on to lithium, which is 1s2, 2s1. And then beryllium, which is 1s2, 2s2. Next, we'll start filling the 2p sublevel starting with boron. Next, we have carbon, then nitrogen, then oxygen, then fluorine, and then neon, which takes us up to 2p6, filling the 2p sublevel. Next, we look at the elements sodium to argon. For these elements, I'm using abbreviated electron configurations. These have square brackets and the symbol for a noble gas. This represents the electron configuration of the noble gas. In this case, it's neon, which is 1s2, 2s2, 2p6. So starting with sodium, we put 1 electron in the 3s sublevel. And next, we complete the sublevel with magnesium, which is 3s2. So next we start filling the 3p sublevel starting with aluminium. Next we have silicon, which is 3s2, 3p2. Next is phosphorus, which is 3p3. Moving on to sulfur, which is 3p4. Then chlorine, which is 3p5. And finally argon, which is 3p6. So as you can see, we've now completed the 3p sublevel. Next we'll look at the electron configurations for potassium to manganese. So once again, I'm using abbreviated electron configurations, but this time the noble gas is argon. So starting with potassium, we put 1 electron in the 4s sublevel. Next is calcium, which is 4s2. We'll now move on to start filling the 3d sublevel. Starting with scandium, which is 4s2, 3d1. Next is titanium, which is 4s2, 3d2. Moving on to vanadium, which is 4s2, 3d3. Next is chromium, which is one of the exceptions to the Aufbau principle. Its electron configuration is 4s1, 3d5. And finally, we have manganese, which is 4s2, 3d5. So next we have iron, which is 4s2, 3d6. Moving on to cobalt, which is 4s2, 3d7. And then nickel, which is 4s2, 3d8. When we get to copper, we have another exception to the Aufbau principle. The electron configuration of copper is 4s1, 3d10. And finally, we have zinc, which is 4s2, 3d10, which completes the 3d sublevel. And finally, we look at the electron configurations of gallium to krypton. In these elements, we are now filling the 4p sublevel. Starting with gallium, which is 4p1. Next, germanium, which is 4p2. Moving on to arsenic, which is 4p3. Then selenium. Next is bromine, and finally krypton. So there you have the electron configurations of the first 36 elements in the periodic table.